Okay, this video is to cover Monday, August 19th. We basically talked about how to create a velocity graph from a position graph. So this was the bell ringer. Describe the motion of an object whose position versus time graph looks as follows. Right. So what we said was that we notice portion A has a steeper slope than portion B. What does that mean? That means the slope indicates that the rate of change at A is faster or let's say greater than the rate of change at B of the position. So the position is changing at a greater rate than it is at B in terms of meters per second. So we know the person is moving faster during A than they are at B. And notice for both segments, though, when you look at them individually, it is a straight line, and that means that the position is changing at a constant rate during A, and then during B at a different but constant rate. Okay, so you can make little steps along that line. Okay, indicating that it changes by the same amount every second. Then at C, the position does not change, right? From the beginning of C to the end of C to any point in the middle of C, if we extrapolate this line over to the left, the object was at a certain position the entire time. So at C, the object is not moving. And then at D, during D, the person changes direction and moves in the opposite direction. The position is decreasing. So for A and B, you could say the person was moving to the right, and then for D, the person was moving to the left. So what we did is we built a little graph in Desmos to kind of model this. So we see the person started off at 0, 0, went to 1, 4, 2, 8, 3, 12, 4, 16, which means that the position increased by 4 meters every second. You can see that information here in the table. X is time and Y is position. So 0, 4, 8, 12, 16. You can see the rate of change. Mathematically, Y equals 4x. Notice 4 is the slope of the line that passes through those points. That is the rate of change of the position versus time for the first 4 seconds. In the second 4 seconds, we go from 5:18 to 6:20 to 7:22 to 8:24. So every second, the position is increasing by 2. So the rate of change is 2 meters per second, right? So in the equation that passes through those points is y equals 2x plus 8. If you're wondering why the line doesn't continue, it's because I've limited the domain. And then we can see here the position at all these different times is 24. So the equation there is y equals 24. And then finally, we can see that the position is decreasing at a rate of 6 meters every second. So the slope is -6. The equation that passes through those points is y equals -6 plus 96. So you're saying why 96? Well, if you were to extend this line all the way up, it would hit the y-axis right about there, 96. Okay. Anyway, the more important concept is the rate of change. So the slope on a position graph is the rate at which the position is changing. Right. So for the first portion of the graph, the rate was 4 meters per second. For the second part of the graph, the slope was 2, so the rate was 2 meters per second. For the third part of the graph, there is no x term in the expression or the equation. That's because the coefficient was 0, so the slope was 0, so the position was constant. And then for this portion of the graph, where the position is decreasing at 6 meters per second, the slope is -6. So at that first point, the object has changed direction, is moving in the opposite direction. Okay. Now, let's say we want to graph the velocity of this event that happened for 16 seconds. Well, let's just look at it one section at a time. So in this first section, we're talking about the fact that the position was changing at a rate of 4 meters per second. So if we were to graph it, it would be, this blue line indicates the velocity, right? The velocity was constant. The person was walking at 4 meters per second. For the second part of the graph, their position was increasing at a rate of 2 meters per second, right? But it was constant. It was increasing at a constant rate. So y equals 2 would represent the velocity in that interval. For the third interval, the velocity was 0 because the position was not changing. So we'd have y equals 0 for this portion down here. And then finally, for the last segment, the position was decreasing 6 meters every second. So the rate was -6 meters per second. That was the velocity, and it was a constant velocity during the entire interval. So if you graph the velocity, it would look like that right there. So these lines right here represent position versus time, and these lines right here is a separate graph of the velocity, the different velocities in each of those time intervals.